Hello my dear viewers, welcome back to my channel Vaishali's mathematics classes. I am Vaishali Fulari. We are solving the fourth question from the 10th standard CBSE board and the chapter name is the arithmetic progressions. In that we are going to solve the sixth question. In previous video till fifth question we have completed. Let us see what is the sixth one. 0.2, 0.22, 0.222, 0.4 times 2 is there. So, whether is it in AP or not? A1 is equals to 0.2, A2 is equals to 0.22, A3 is equals to 0.222, A4 is equals to 0.4 times 2. It is given to us. We have to find A2 minus A1 because whether is it in AP or not, we have to check. After doing A2 minus A1 and A3 minus A2 and A4 minus A3, if they are the same, then we can declare it is in the AP, otherwise it is not in the AP. A2 is 0.22 minus A1 is 0.2. The subtraction of this is 0.02. Next, get A3 minus A2. A3 is 0.222 minus 0.22. The subtraction of this is 0.002. Here we got 0.02 and here is the 0.002. So both are not equal. Here we can write it as A3 minus A2 is not equals to A2 minus A1. Therefore, we can write the given list of the numbers are not in the AP. Therefore, the given list of numbers are not in AP. The given list of the numbers are 0, minus 4, minus 8, minus 12 and so on. Let us take A1 equal to 0, A2 equals to minus 4, A3 is minus 8 and A4 equals to minus 12. Let us do A2 minus A1. A2 is minus 4 minus A1 is the 0. Minus 4 minus 0 is minus 4. A3 minus A2. A3 is minus 8. Minus of A2 is the minus 4. Minus 8 minus into minus is the plus 4. Minus 8 plus 4 gives us minus 4. Here A2 minus A1 equal to A3 minus A2. From this we can write therefore the given series is in the AP. It is in AP. What is AP? Arithmetic progression. You already know it. Next, we have to find out the next three more terms. We have to find A5, A6 and A7. To get A5, A plus 4 into D, A is what? 0. But here we have to find out the common difference also. What is the common difference? D is equals to minus 4. This is nothing but our common difference. How can we determine the given series is in AP or not? If we get the same common difference, then we can say that the given list of the numbers are in the AP, otherwise not. So we got the same common difference. That's why directly here we have written D is equals to minus 4. Next, 0 plus 4 into D is minus 4. 0 plus into minus is minus, 4 4s are 16, minus 16. Next, A5, A6 equal to A plus 5 into D. A is the 0 plus 5 into minus 4. 0 plus into minus is minus, 5 4s are 20. We'll get the minus 20. Next, A7, A plus 6D. A is 0 plus 6 into D is minus 4. 0 plus into minus is minus, 6 4s are 24. 0 minus 24 is minus 24. We found next to 3 terms. Therefore, we will write D is equals to minus 4 and minus 16, minus 20, minus 24 are 3 more terms. Eighth problem, minus 1 by 2, minus 1 by 2, minus 1 by 2, comma minus 1 by 2. A1 is equals to minus 1 by 2, A2 is also minus 1 by 2, A3 is also minus 1 by 2 and A4 is also the same, that is minus 1 by 2. We have to find out A2 minus A1. A2 is minus 1 by 2 minus of A1 is again minus 1 by 2. Minus 1 by 2, minus into minus will become plus. Plus 1 by 2 and minus 1 by 2 will get the 0. A3 minus A2. A3 is minus 1 by 2 minus A2 is minus 1 by 2. Minus 1 by 2 plus minus 1 by 2 which is equals to 0. So, for these two, A2 minus A1 is equals to A3 minus A2 because for both of them we got the terms as the 0 and 0. Both are equal. Therefore, it forms an arithmetic progression, that is AP. We have to find out the next 3 more terms. It is also asked we have to calculate the common difference. Calculate the common difference here. Common difference D is equals to 0. We found D is equals to 0 and A is equals to minus 1 by 2. Calculate A5. A5 is A plus 4D. A is the minus 1 by 2 plus 4 into 0. It is the 0. Minus 1 by 2 plus 0 is the minus 1 by 2. Next, A6 equal to A plus 5 into D. A is minus 1 by 2 plus 5 into 0. Minus 1 by 2. In the same way, can we get A7 also? A7 how can we calculate? To the previous term, if we add the common difference, minus 1 by 2 plus 0 gives us the minus 1 by 2. Therefore, D is equals to 0 and minus 1 by 2, minus 1 by 2 and minus 1 by 2. These are the next terms. We'll write the given series as 1, 3, 9, 27 and so on. We'll take A1 equals to 1, A2 equal to 3, A3 is equals to 9 and A4 is the 27. First we have to calculate the A2 minus A1 and A3 minus A2, their common differences. A2 minus A1 is 3 minus 1, that is the 2. Next, A3 minus A2. A3 is how much? 9. Minus A2 is the 3. 9 minus 3 is the 6. From this we can write A2 minus A1 and A3 minus A2 both are not equal. Is not equals to A3 minus A2. If their differences are not equal, then what can we write? Therefore, the given list of the numbers are not in the AP, or therefore the given list of numbers does not form an arithmetic progression. Or not in the AP. Next, take the 10th question. A, 2A, 3A and 4A. This is given to us. Let us take A1 is equals to A, A2 equal to 2A, A3 is the 3A and A4 is the 4A. Calculate A2 minus A1. A2 is 2A minus A. It is A. A3 minus A2. A3 is the 3A minus A2 is 2A. It is A only. If we calculate A4 minus A3, then also 4A minus 3A we will get A only. So, the given list of the numbers forms an AP. A2 minus A1 is equals to A3 minus A2. Therefore, the given list of numbers form an AP. If it forms an AP, first thing what we have to find? Common difference D. Therefore, the common difference D is equals to what? It is the A. Next, get 3 more terms. We have D is equals to A and A is equals to, that is the first term, that is also the A. A5 is equals to A plus 4 into D. A is the A only, plus 4 into A. A plus 4A, it will be 5A. A6 is equals to A plus 5 into D. A plus 5 into A. A plus 5A, which is the 6A. Next, A7. A plus 6D. A is the A, that is first term is the A only. 6 into. Common difference is also the A. A plus is 6A, that is the 7A. Therefore, D is equals to A and 5A, 6A, 7A are 3 more terms. Terms of given AP. Eleventh one, A, A square, A cube, A to the power of the 4. A equal to, A1 is equals to A, A2 is A square, A3 is the A cube and A4 is the A to the power of the 4. A2 minus A1. A2 is the A square minus A1 is the A. If we will take A common from it, then it will be A minus 1. Next, a3 minus a2 as a cube minus a square. If we will take a square common from this, a minus 1 it will be. If we see these two terms, both are not equal. a2 minus a1 is not equal to a3 minus a2. Therefore, the given list of the numbers are not in AP. The given list of the numbers in the question number 12 are root 2, root 8, root 18, root of 32. A1 equals to root 2, A2 is root 8, A3 is the root 18 and A4 is the root of 32. Let us get A2 minus A1. A2 is root 8 minus A1 is the root 2. This root 8 can be written as root of 4 into 2 minus 2. Minus root 2, sorry. Here root 4 into root 2 we can write. Root 4 can be written as 2 root 2 minus root 2. 2 root 2 minus root 2 is the root 2. Next. Here I want to write this root 8 as root 4 into 2. Root 4 into root 2, this can be 2 into root 2, which is the 2 root 2. Next, root of 18. Root 18 can be written as root of 9 into 2. Root 9 means, we know that it is the 3 into root 2. Next, root 32 can be written as root of 16 into 2. Root 16 can be written as 4. 4 into root 2. Isn't it? Okay. Now, calculate A2 minus A1. Now, we will do the A3 minus A2. A3 is what? A3 is the root 18 minus A2 is the root 8. Root 18 we calculated it as the 3 root 2. 3 root 2 minus root 8 can be written as 2 root 2. 3 root 2 minus 2 root 2. We will get simply the root 2. From these two, can we write A2 minus A1 is equals to A3 minus A2? Yes, both are equal here. A2 minus A1 is equals to A3 minus A2. Therefore, it forms an AP. Therefore, it forms an AP. So, we have to get the common difference. What is the common difference? Common difference D is equals to root 2. Let us get the next terms. A5 equal to A plus 4 into D. A is root 2, that is nothing but the first term, plus 4 into D is how much? Root 2. Root 2 plus 4 into root 2. 4 root 2 plus root 2. Before this, if nothing is there means we can take 1. 4 plus 1, 5. 5 into root 2. Then this way. Here, the terms are in this, completely it is in the root. Then, how can we convert them into the root 2? See here, if this 5 it is right now it is at the other side. If this 5 goes inside, it will become the square of it. Root of, we can write 5 square, that is into 2. 5 square is the 25 into 2 is the root of 50. Next, A6. A plus 5 into D. A is root 2 plus 5 into root 2. Root 2 plus 5 root 2. If we add both of them, we get the 6 root 2. We can write this as 6 square, 36 into 2. 36 into 2, it is the root of 72. A7. A7 is equals to A plus 6 into D. A is root 2 plus 6 into D is also the root 2. Root 2 plus 6 root 2. If we add both of them, we will get the 7 root 2. Root of 7 square is the 49. 49 into 2 is the root of 98. Therefore, D is equals to root 2 comma root 50, root 72 and root of 98. These are the next 3 terms. Let's take the 13th question. Root 3, root 6, root 9, root of 12. A1 as root 3, A2 as root 6, A3 is equals to root 9 and A4 is equals to root of 12. If we do A2 minus A1, A2 is the root 6 minus root 3. Here we can't write it as the, because it is not the perfect square of anyone. So which can be written as root 2 into root 3. So we can't further do the simplification of this. We have to leave it as it is. Next, A3 minus A2. A3 is the root 9 minus A2 is the root 6. We can write this root 9 as the root 3 only minus root 6. So we can't do the further simplification now. If we see here, A2 minus A1 and A3 minus A2 both are not equal. A2 minus A1 is not equals to A3 minus A2. Therefore, the given list of the numbers are not in the AP. Does not form an AP. Let's take the second last question from the fourth one. 1 square, 3 square, 5 square and the 7 square and so on. Let us convert here only. 1 square is the 1, 3 square is the 9, 5 square is 25 and 7 square is the 49 and so on. A1 is equals to 1, A2 is the 9, A3 is 25 and A4 is the 49. Do A2 minus A1. A2 is 9 minus 1 is the 8. A3 minus A2. A3 is 25 minus A2 is the 9. 25 minus 9 is the 16. A2 minus A1 and A3 minus A2 both are not equal. Therefore, the given series does not form an AP. It is not in the AP because their common differences are not equal here. Okay friends, let's discuss the last question of this exercise. 1 square, 5 square, 7 square, 73 and so on. Convert here. 1 square is the 1, 5 square is 25, 7 square 49 and the 73. It is not the square of anyone, just it is given the number as the 73. Let us take A1 is the 1, A2 is 25, A3 is 49 and A4 is the 73. Calculate A2 minus A1. 25 minus A1 is the 1, 24. Next, get A3 minus A2. A3 is 49, A2 is 25, 9 minus 5 is the 4, 4 minus 2 means it is the 24. So A2 minus A1 and A3 minus A2 both are equal. Therefore, it forms an AP. The given list of numbers are in AP. If they are in the AP, two things we have to find. What is the first one? First is the common difference D and the next three terms. Therefore, the common difference D is equals to 24. We'll get the next three terms. Next three more terms. A5 is equals to A plus 4 into D, because here A1, A2, A3 and A4, 4 terms are given. We have to find out the next three more terms. A5, A6 and A7. A5 will be A plus 4D. A is the 1 plus 1 square is the 1. 4 into D is the 24. 1 plus 4, 4 is a 16, 4 2 is 8 plus 1. It is the 9 because 1 was the carry. So 96 plus 1, 97. Next, A6 is A plus 5 into D. A is 1 plus 5 into 24. Because D is a 24, we found it as the 24. 1 plus 5 4 is a 20, 2 is the carry, 5 2 is a 10, 10 plus 2 is the 12. 120 plus 1, 121. Next, A7. A plus 6 into D. A is 1 plus 6 into 24. 1 plus 6 4 is a 24. Carry 2. 6 2 is a 12. 12 plus 2 is the 14. 144 plus 1 is 145. So, therefore, D is equals to 24, 97, 121 and 145 are 3 more terms. So, this was the question number 4. In this, we have solved from the question number 6 to the 15. We completed this question and the exercise 5.1. Keep watching my videos and thank you.